Hello there, and welcome to our talk. Today, my colleague Yulian and me, Uladzimir, will share with you some insights on how to make your PDF recipe shine. For this purpose, we've prepared for you 5 ingredients, so let's not wait and start with the first one. And you may wonder why we have chosen such a simple topic as table of contents as one of the talk's points. Well, firstly, although it has been covered in numerous Stack Overflow questions, our support team still gets questions regarding their creation. And secondly, and that's the main point here, with the help of table of contents, one can understand one of the basic iText concepts, the render framework. Basically, the iText layout engine consists of 2 hierarchies. One starts with iElement and the other with the iRenderer interface. The element interface is implemented by such classes as div, paragraph, and so on. To generate a PDF usually means to create several instances of these classes, customize them by setting appropriate properties, and finally add them to the document. However, under the hood, iText operates with instances of the iRenderer hierarchy. For each of the mentioned element classes, there is a corresponding renderer class. To name some of them, text renderer, paragraph renderer, and so forth. These renderers are responsible for 2 tasks mainly. First, to lay out an element, and that means to define where exactly the element should be placed, how much space it should occupy, and how its layout affects layout of the other elements. And the second one is to draw the element. And what's important for us, if needed, one can easily subclass them and tweak the default behavior. So now we come to the table of contents problem. Suppose we want to collect the page numbers of all the document's paragraphs and add links to them at the end of the document. How should we proceed? The answer is obvious. As the first step, let's subclass text renderer and set its instance at the text's next renderer. So as you can see on the slide, we apply set next renderer on a title. Then, as a second step, when a paragraph gets drawn, we can save the number of the page its title occupies. And at the third step, we can use the collected page numbers to build a nice table of contents. So that's it. With such a simple customization, we successfully tweaked the default paragraph layout behavior and produced the desired PDF. The same concept could be used in other cases, of course. Alternating a table's background, writing text to columns of peculiar areas, whatever. Actually, with the help of this powerful framework, we've been able to add out-of-the-box support for flex layout, target counters functions, running elements, and hopefully many more other features will be shortly added to this list.
Okay, I hope it's not too noisy from my side. So Uladzimir has discussed how to make the document content richer. However, making a great document also requires considering aspects which are not directly related to content representation. The way the document is built internally defines its usability in different scenarios and associated costs to its processing. So let's start with the classic example, handling of graphics. An optimal approach can vary depending on the use case. Raster images have a terrible size-quality trade-off when compared to vector graphics. But, well, of course, vector graphics are not applicable to each use case. Like in this example, on the left is some arbitrary image, and on the right, well, this is the best I could do to reproduce it with vector graphics. Okay, so let's say we are dealing with an iText logo. In that case, we would probably want to make use of vector graphics in PDF. On the screen is an example of how vector graphics are defined inside the PDF file. Essentially, there is a list of basic operators that allow you to draw graphical primitives like lines, arcs, rectangles, and so on. And the straightforward way to make use of vector graphics would be utilizing the low-level API for PDF syntax. Code-wise, it means using the PDF canvas class. Basically, it's a clever wrapper for the PDF content stream operators that we have seen on the previous slide. Well, as you can see, though, this approach is quite cumbersome. Much more convenient approach would be to rely on an SVG converter. For sure, it is much easier to create and support. Like if you have an image, you can immediately see the result, and you don't need to know actually to code in order to work with it. And the conversion logic is just as simple as in the example that you see on the right. Convert an image and add it to the document. So usually it's best to think about optimizing the result well in advance. But sometimes decisions were made long ago in different circumstances, or simply that a mistake was made at one point. So what options do we have in this case? One of the options that we can suggest is the iText 7 PDF Optimizer add-on. This is one of the many add-ons for iText 7, and together with Core, they comprise the iText 7 suite. Looking back at the previous example about graphics handling, PDF Optimizer can fix some of the possible mistakes by adjusting the contents in order to better fit the specific use case. So if you don't care about details too much, you can compress images as JPEG. And in this particular case, compression artifacts are, even barely visible. Or you can downscale the resolution of images if the actual image dimensions on screen will be small. Like here, pixels won't be noticeable if you make image small enough. And the JPEG compression from the previous slide was performed with the code that you see at the top. That's more or less a usual way how you would code with PDF Optimizer. And the example with that extreme downscaling, it required a little bit of customization, but not really that much, in fact. Okay, PDF Optimizer helps to remove redundancy, but sometimes the redundancy is not caused by any mistakes. For example, when documents are merged or flattened, new possibilities for optimization can be created. Have a look at this form on the left. Let's say we want to flatten the field forms and merge multiple instances of them together. Often in this scenario, the resultant document would not only have duplicated resources, but also fonts would contain unnecessary data for unused characters. In such cases, the effect of optimization can be really substantial. Sorry, I don't think I hear Uladzimir.
And now?
Yeah,
it's much better. Okay.
That was some technical difficulties. Maybe let's start from the beginning with this chapter.
Oh, yeah, no problem. So working with PDF often means dealing with fonts. When you try to write hello world in Latin using Helvetica or Times, then the task is relatively simple. However, once you try to write hello world in Thai, for example, or Arabic, then suddenly everything gets much trickier. So when written in a straightforward manner, the text doesn't look familiar to the native speakers. It lacks shaping, the glyphs are wrong, and as a result, the customers are unsatisfied. The solution is, of course, the iText 7 PDF calligraph add-on. Adding just one dependency resolves all the issues at once, so that you don't need to know anything about the transformations which are silently performed under the hood. But perhaps you do want to know about them. Perhaps the default font processing, although perfectly correct, is not enough for you. Well, If that's the case, then PDF Calligraph has a simple but efficient solution, typography configurator. As the documentation says, this class allows you to apply certain font features to specific scripts and to configure it on a high level of iText layout elements. So let's take a look. Suppose that I want to create a PDF and write some thoughts on our event there. The code is straightforward and looks just like on the screen. Well, so far so good, but wait a minute. Yulian doesn't like the hidden paragraph and insists that the 0 in the year should be slashed rather than plain. Well, it might sound like a strange requirement, but I do believe that your customers may have even more peculiar needs. So I've searched on the internet and found a font which contains the required feature, set it on the paragraph and generated, well, pretty much the same PDF. The font is different, that's for sure, but the 0 is still plain. And here comes typography configurator. Basically, to configure it, one needs to specify just two things: the scripts for which the transformations should take place, and the exact font features to be enabled. In our case, the script is Latin, so Latin script config beat, and the feature name is 0. Well, and actually, one should inspect the font's documentation to find out which feature to choose. Well, that's it. With such a simple bit of code, I enabled /0 functionality and made Yulian happy. But typography configurator is of course not only about /zeros. Utilizing its powers, you can make PDFs beautiful regardless of the script. Devanagari, Hebrew, Cyrillic, whatever you need. For some of the features, there are some predefined methods. The others need to be tuned, so play around, and I'm sure you won't be disappointed.
Okay, and let's continue taking control of various aspects of the document layout. Well, PDF is an example of page media, in the sense that its content is visually split into discrete content areas associated with pages. And of course, this is an old media with a number of well-established practices on how the content should be placed. For example, page numbers are usually found somewhere in the page corner, and document footers and headers are found on the page margins. And similarly, iText is known to provide a variety of approaches of how such layouts can be generated, ranging from page event system to document post-processing. And well, today, I'll focus on how pagination can be fine-tuned in the context of HTML to PDF conversion with the PDF HTML add-on for iText 7. In the HTML world, paged media concept is not native. However, there is a dedicated chapter in the CSS specification that describes how HTML should be served if, for example, it is printed on pages. One of the key concepts is page margin boxes. Let's see how they are normally configured. On the left, you can see how margin boxes are defined in the CSS syntax. And there are 16 potential margin boxes per each page, regardless of its size and orientation. On the left, you can see how margin boxes are defined. That's basically the idea. And yeah, you can actually only choose some of the boxes. PDF HTML will automatically distribute the available space between them. And here on the top and on the bottom, you can see that all of the boxes are present. And if some of the boxes are omitted, the available space is automatically distributed between the remaining boxes. The box content can be set up in a few ways. If margin box content is simple enough, you can either set it up with static content, well, text or images, or even utilize some of the predefined dynamic CSS functions like target counters. So in order to, for more complicated content, however, one can rely on the running elements mechanism. And this mechanism, one of the normal elements from the page can be marked as running. And this way, this element would be extracted from the normal flow, and it would be moved to the designated margin box area. Like here, the topmost block on the left has position running style, and below you can see how this element is referenced. And that's how the running elements work. And one last thing that I wanted to share with you is a neat trick with the running elements. The thing is that if viewers don't support them, and most of the common browsers, for example, they actually don't usually support them, running elements are just shown next to the main content. And of course, that would ruin the document if one opened HTML in normal browser. So Yeah, let's try to avoid it. Let's utilize CSS media rule. It allows you to configure styles specific only to some media, like print, screen, and so on. And here in CSS, we can override the display none property in order to make it visible only for print media. And in PDF HTML code, well, it's very simple. We just select print as the target media for conversion. In the end, there is no single definitive recipe for fitting each use case. So instead, we want to leave the last ingredient up to you. No one knows your users better, and no one but you can make an ideal solution with our toolset. And to let you make the best of iText 7 Suite, we provide rich documentation, and if that's not enough, you can always find help from our Stack Overflow community. And during our talk, we've mentioned a few add-ons. However, iText Suite has much more to offer. You can find all the necessary information at our website, or join our virtual booth. Well, it will be just in a couple of minutes. I'm pretty sure we will be able to find something specific to your needs. And small, but still yet another addition to our documentation. You can find examples from this talk at the GitHub repository that you can see on the screen. These samples and most of the code that we have shown were written in Java. However, we are proud that we provide native.NET version for all of our libraries. Okay, so if you would have any questions, as I've mentioned, please join the next event in the schedule. And of course, if you have any questions left at any time, feel free to reach us or reach our support team. We are more than happy to help you.